Hello class, and welcome to day 1 of section 1.3, which is about solving equations with variables on both sides. By the end of today's lesson, you will be able to write and solve equations that include variables on both sides. So starting off, this is very similar to yesterday's lesson. We want to make sure we are following SAD-MEEP and simplifying expressions as we go. So our first step on this one is we see that there are parentheses that allow us to do the distributive property. So we're going to say we've got half n. Personally, I like to convert that to decimals. So 0.5n minus 1/2 of 4, which is 2, minus 7 is equal to negative 2n plus 6. Because we have like terms on the left side of the equation, we're going to go ahead and combine those, which gives us 1/2 n minus 9 is equal to negative 2n plus 6. So right now we have all of our like terms combined, and we're going to have to start moving things from side to side on the equation. My suggestion to you is to start by moving the variables and combine those first. That is not necessary, but personally I find that it's easier to move the variables to make them positive. So in this case, I'm going to get rid of this negative 2n by adding 2n to both sides. You do not divide here. A lot of students like to try and divide to get rid of a variable, but since there are two variables showing up in the equation, you need to make sure those are combined first. So everything needs to be on one side and the variables need together before you are ever allowed to divide. So when I add this, I get 2.5n minus 9 is equal to 6, and then you can continue just like you would with any other SAD-MEEP problem. So I'm going to go ahead and add 9 to both sides, giving me 2.5n is equal to 15. And then we're going to finish up now by dividing by 2.5. And 15 divided by 2.5 is going to give me 6. Again, you can always check your answer by plugging it back in. If I take 6, 6 minus 4 is 2, half of 2 is 1, 1 minus 7 is negative 6. Negative 2 times 6 is negative 12, plus 6 is negative 6. So both of those sides of the equation end up being equal. You can always plug your answer back in to check it. Go ahead and try this one on your own. Going through and solving, first by distributing, then by combining your like terms, and then using SAD-MEEP, you are going to find that x is equal to 3. A couple other specific types of cases that I want to talk about. This first one, again, we want to start by distributing just like we would with any other problem. So our left side stays the same, 4x plus 6, and then after we distribute, we get 4x plus 6. Like I said before, I would suggest combining your variables first. So I'm going to subtract 4x from both sides. And I notice that 6 is equal to 6. You may have noticed back up here that 4x plus 6 is equal to 4x plus 6. Both things were the same on both sides of the equal sign. When this happens, we call this an identity equation because both sides are equal to each other. When you have this happen, the answer to the problem is all solutions. It does not matter what number you plug in. It will always give you the same answer. So for example, if I do 4 times 10, which is 40, plus 6, I end up with 46. If I do 2 times 10, which is 20, plus 3, which is 23, times 2 is 46. If I did another example, if I did 4 times 20 is 80, plus 6 is 86. If I do 2 times 20, I get 40, plus 3 is 43, times 2 is 86. And you could keep going with all possible numbers that you can think of. So if you end up with something where both sides of the equal sign are the same, this is the identity, also known as all solutions. If we come down to this bottom one, and I start doing my distribution, I'm going to get 6x minus 5 is equal to 6x plus 8. When I combine my variables on this one, I'm going to go ahead and subtract 6 from both sides, and I end up with negative 5 is equal to positive 8. We all know that that isn't true. When this happens, we call this no solution. You cannot find a number that will make those two sides of the equations equal. You may have noticed back up here, you had two 6x's with a different value being added and subtracted. So one thing that you can do is if you end up with the same variables, in this case it was 4 and 4, in the second case it was 6x and 6x. Look at what's being added or subtracted. If it's the same, plus 6 plus 6, it's all solutions. If it's different, minus 5 plus 8, it's going to be no solutions. Go ahead and try this one on your own. After we distribute, we're going to end up with 64 minus 48m is equal to negative 48m plus 96. Our variables are the same, but the other numbers are different, giving us no solution. Now we're going to do a couple of word problems. Two different bowling alleys are offering a promotional price. For how many games is the total cost of bowling and shoe rental equal at the two locations? So when we're looking at this, we're looking for the number of games that it's going to cost. When you walk into a bowling alley, you only have to put your shoes on once. So this is only going to happen once at each place, and the games are what's going to be changing or what goes with our variable. So for family bowl, we've got $4 per game plus our $1 for shoe. For night owl bowling, we've got $3.75 per game plus $2 for shoes. Now, the problem says, when are they equal? So it's asking us to take those two equations and set them equal to each other. So we got 4g plus 1 is equal to 375g plus 2. We're going to go ahead and combine our variables using SADMEEP, subtracting to get rid of my positive 375. And when I do that, I'm going to end up with 0.25g plus 1 is equal to 2. My next step is going to be to get rid of that plus 1. So I'm going to go ahead and subtract 1 from both sides, giving me 0.25g is equal to 1. When I divide by 0.25 on both sides, I find out that g is equal to 4 games. So when the person plays 4 games, the price is going to be the same at both bowling alleys. Go ahead and try this one on your own. So we set our two services equal to one another. This one doesn't have anything being added or subtracted because it's just 95 cents per song. Once you go through and solve, you find out that at 200 songs, both services will cost the same price. The last thing I want to talk about with equations with variables on both sides is the percent of change equation and finding original values. In Chapter 0, we use the percent of change equation to find final values. Now we're going to use it to find original values. So a quick reminder that our percent of change equation is final minus original divided by the original, and that's going to equal our percent in decimal form. So, if we've got this problem, the number of calculators in Miss G's room decreased by 66.7% during the school year. If there were 10 calculators at the end of the year, how many did she start with? So instead of looking for this final like we did last time, we're looking for the original. So we're going to plug in the information that we know. At the end of the year, I have 10 calculators in my classroom. I'm not sure how many I started with, so I'm going to put in X, or my variable there. Then it says a decrease of 66.7%. So decrease, and then we need to turn it into decimal form, so 0.667. Now, to solve this, we've got to get rid of the X on the bottom. So we're going to go ahead and multiply both sides by X, giving me 10 minus X is equal to negative 0.667x after we multiply. Then I need to combine my variables, so I'm going to go ahead and add an x to both sides. Remember, when you're adding x, you are adding 1. So when I do that, I'm going to end up with 10 is equal to 0.333x. My next step in the problem is going to be to divide by 0.333. And when I do that, I'm going to get a value of x is equal to 30.03. Now, since we are talking about calculators, and we can't have 0.03 of a calculator, you would say that I started the year with 30 calculators. Go ahead and use the percent of change equation to try this one on your own. After rounding, we find that 162 students attended the school in 2000. Again, remember with the rounding, if you need whole items, so people are whole values, we have to round down because 0.7 can't round up. We don't have enough for that 163rd person. If you have questions about this or anything else from the lesson, please let me know when you get to class.